You can see my screen?
Yes, very clearly. Thank you.
Very good. Hi, my name is Adrish Sannyasi. I'm a solution manager in Google Cloud Healthcare Life Sciences. And today I'm going to walk you through some of the best practices of building AI applications or machine learning applications in a healthcare settings. Generally, the workflow in any healthcare, any machine learning environment is there are three distinct phases. One is the design and development, while you design the model, develop the model, and experiment the model, and then you have the validation, evaluation stage, and then you have deployment, monitoring, maintenance, scaling, etc. So go through each and every stage and provide some of the learnings that we have from various implementations or some of our thoughts in these domains. As I mentioned, design, development, validation, this is like a software engineering type of life cycle, and it goes through iterations. It's not a single sequential process. And once you implement and deploy, and then you also go through this continuous monitoring and maintenance types of situation. And the fundamental idea is to integrate a couple of disciplines together in order to create like a factory type of environment for implementing AI in healthcare. Okay, ML engineering that will help you design and develop the model, software engineering that will help you implement CI/CD types of pipeline, and then security that will help protect the infrastructure, patient privacy, and etc. And the FHIR is the key in solving one of the biggest issue in healthcare AI, which is producing reliable and reproducible models. Because when you have the data from multiple sources and there is no common representation, it's very difficult to integrate data from the sources and have a common semantic definitions. Second, let's say you develop a model for a source A and you want to apply in source B, there isn't a common definition, so you'll be spending a lot of time in data integration and semantically mapping things from one source to another. So FHIR solves a very significant problem in reproducibility of models in healthcare. And this is a reference architecture, using some of the capabilities in the Google Cloud, but you can always implement in any other environment that you have. Some of my colleagues probably talked to you about FHIR store and corresponding BigQuery SQL store that you could do in a streaming fashion in Google Cloud environment. After that, you can apply something like a DID mechanisms that will create a partial or can you see my screen?
Yes, very clearly.
Yep. Partial services, partial store like where you can make that data now available to variety of individuals like the machine learning engineer, startup company, or maybe to other participants. And then in that environment, you can create synthetic data that might be needed for some of the AI training, because many of the features or many of the labels may not be available. So data labeling is also a significant activity. So all of these things you could do in this DID environment. And then once you develop and train the model, then you store the model in a production or there's target environment, and where now you can have the streaming data coming in the FHIR store and have a function that will execute these models that is implemented in production. And then the output of the model could be a FHIR resource as well. Like, for example, it could be an observation resource, or could be a FHIR risk assessment resource that then could be integrated into an engagement applications like EHR, it could be a dashboard, etc. And behind the scene, you want to implement some of the capabilities like model artifact management, lineage tracking, model performance monitoring, etc. And along with that, then you implement a kind of a CI/CD infrastructure like you do in software engineering, where you have different pipelines for different stages of implementation, like experimentation phase and a training stage, training and evaluation stage. And then once you have a concrete idea about the model, then you want to implement a continuous training in a production settings. And there are several due diligence you need to do before you start the project. And then I'm just going to describe some of the due diligence related to data. First is data quality assessment, the performance of the data, accuracy of the data, and also, more importantly, data distribution across the sources. Because source A might have a population which is different than population in source B. One maybe have a senior population, another may have a young population. So it's very hard to apply a single model. You may have to decide on creating, let's say, multiple models in that kind of situation. And that is where the concept of training serving skew comes in, where your historical data might be different than your testing data or than your live data. So relationship between the predictors and the labels might change over time because of the change in the business model or change in some of the things like new device or new drug, etc. The second due diligence related to data is around the data availability assessment. What that means is, when I'm executing the model, do I have access to the same data that is used to create the model, so that I can have the same features, I can create the same features with the live data as well. And lastly, around the data is understanding the bias in healthcare. But you may not be able to remove all the biases, but if you understand the biases, you may be able to document some of the biases so that people understand who is using the model, what type of things that they have to worry about. Like, if you see there are kind of different biases, selection bias, because somebody may not have insurance, and etc. Somebody may not go through exact same exams. So there's a lot of classification bias and the information bias. So one of the ways to overcome these biases is to do a couple of things. First is, you have to verify across multiple resources. For example, if you want to create a diabetic cohort, don't just look at diabetic diagnostic code. You may have to look at procedure, medication related to diabetes, or the lab test to confirm that that person really has a diabetes. Same thing around validation across the sources. If you can combine inpatient, outpatient, and telehealth encounter data, you may have better chance validating things across, and creating the FHIR representation is actually key for understanding this kind of complexity in the bias. And lastly, maintaining the provenance and lineage of the data. Either you can use the FHIR provenance resource or any other tables to document the sources of data, metadata, and also how the data is actually used in various models. Then I'm going to quickly go through some of the test steps on the creating the ML data sets, and you can actually go through that later in the presentation because I don't have enough time right now. Just going to walk through very quickly. First is organizing data by patient timeline. Because a lot of the deep learning model actually requires sequential data. So, or maybe it's required for, let's say you want to use first 3 years worth of data for training and next 2 years worth of data for testing purposes. So having this data by timeline is really important. Then you define the prediction task. Basically, you need to have a label. So you can use some of the data sets in the FHIR tables or FHIR resources to create this kind of labels. For example, here you can use encounter table to create length of stay. And then selection of the cohort. You can use the definition that is given by some of the expert sources, like FHIR.org or any other sources that you come across. Basically, agree on some kind of definitions and use that definitions to create your cohort. And this is one example from the FHIR data where you can see I'm creating a diabetic cohort by looking through medications and encounter and then observation resources. In terms of the creating new feature, the FHIR may not require, in the deep learning era, you may not need a lot of features created manually. But there are a couple of cases like, aggregation of the code, like a lot of codes in healthcare, you may want to aggregate some of the codes. And there's a lot of other things like creating risk adjustment scores based on the comorbidity burdens and so on. Now let's go through the next stage of the model. That's the validation and evaluation of the model. So I'm not going to go through some of the basic stuff that you have to go through anyway, like a ROC curve or F1 score, etc. Those are the indicator of accuracy. But beyond accuracy, there are certain framework you want to be in place so that you can evaluate your applications effectively. First is utility of the model. Is there any action that someone could take based on the model output? Is the person is ready to take that action? Is the person has the authority or resources to take the action? And then if the action is taken, what are some of the cost, like a workflow integration, IT integration, or implementation and maintenance cost for making that work in your production environment? And then impact, whether the output is having impact in terms of revenue, in terms of clinical care, in terms of the patient outcome, or operational efficiency. A quick test to see whether the model is effective is to do a lead time check. For example, you are creating a readmission model, for example, and you want to, have the model executed before the discharge time, well before discharge time, so that clinician or somebody has time to intervene. Maybe they want to create a primary care appointment, or they want to do some kind of adjustment in the medications or provide some educational material. So having the model executed at the right time is really important in order to make that model effective. And that's a lead time check you could potentially do. Second is there is a lot of other things you have to do. For example, resource capacity, whether you have enough resources to take care of the patient, even if you know who is going to be readmitted in the hospital. Then a couple of other scenarios that might appear in many situations, like FDA approval, regulations, or incentives, and then patient privacy and consent, etc. Now I want to go through some of the last stage of the model stage, which is like a model deployment, monitoring, and maintenance. Here, this is the same architecture that I described before. So this architecture is actually could be utilized not only for the model training, etc., but you could use the same architecture for model deployments and model performance monitoring in production settings. And you can complement that, the CI/CD process that you saw before by using another CI/CD process for reliable model deployment and monitoring. For example, you can get the resource repository that you have seen before, and then deploy it to the target environment, then have the live data coming in and in that infrastructure. And in the cloud environment, you can actually scale up and down based on the depending on how much for the data you are coming in the live data, you could scale up and down based on the needs. And of course, you want to maintain all the logs that is happening in the environment for the purposes of audit and purposes of learning from how people are using the system, and using that to kind of making sure that the models are actually working and data is really useful for the purposes of execution of the model. So there's a key takeaways, the three key takeaways from this presentation. So one is in the design and development stage, understanding your problem and understanding your data is the key for the success. The second one is in the validation and evaluation, beyond model accuracy, you want to focus on utility, feasibility, and impact of the model. And lastly, in the deployment stage, and make sure you have a continuous data validation and the model performance monitoring system. And I've added a lot of references here so that you can look at. There's a lot of code base here, and also there are a variety of materials, including presentations, papers from Google and outside Google to give you some idea about how deep learning and other technologies are used in a healthcare AI environment. And there's some related presentation from Google Cloud on a very similar topic, similar analytics and AI topics today. And some other things happened actually yesterday as well. And I'm available for questions. You can reach out to me via social media, etc., and also available in the app.
All right. Thank you very much for your clear presentation. I actually have a question. You told us that what you should keep in mind, for example, with the lead time check for model effectiveness. Are there other takeaways that we can learn of to not make the same mistakes that you might perhaps have made?
Yeah, so I think there are a couple of, I want to go back to there. So there are, obviously, lead time check is one of the checks Alga is going to say, it's an effective one, and you can see whether the model is really working. But there are many things you want to do, like understanding the, threshold and deciding at which threshold will be giving you the better economic validity of the model. For example, you have to balance between the true positive and false positive, etc., so that you define the threshold, whether it's a 0.5 in case of classification model or something else, based on the net benefit, balancing true positive and the true negative. And then of course there's other things like who is the beneficiary of the model. Understanding the beneficiary is actually included in the model development process. All the stakeholder must be included in the model development and model evaluation, so that they know what is coming and how they could prepare for changes that might happen in their life. And they should be able to take action, and authority should have authority and the incentives to take actions.
All right, thanks. I have one other thing to ask. You showed a list of references. Is there one in particular that you might want to elaborate on a bit, that you can show, which might need some extra explanation?
I'll go through some of the, there's a deep learning paper from Google, and there are some other deep learning paper from Emory University that has talked about on the deep learning architecture. The sequence model that I talked about is utilized, so you can, and there are some of the open code available also for some of these models, so you can look at and then see how actually used as a pipeline, how to create the pipeline from the FHIR resources up to TensorFlow.
All right, thank you very much. I would like to thank you for your time and your great presentation, and yeah, enjoy the rest of your evening or morning, actually, maybe for you. And yeah, hope you enjoyed DevDays so far and have fun tomorrow as well. Thank you.
Thank you.